So we are seeing the rate law. Okay, so what is the rate law of a reaction? Rate law is, suppose consider a reaction AA plus BB is giving CC. Okay, so how we can write the rate of the reaction? Rate of the reaction could be written as R equals to K A raised to the power X and B raised to the power Y. Now, where X plus Y represents the order of the reaction. Order of the reaction. Okay. So, order of a reaction. Okay. Rate law is a mathematical expression which correlates rate of the reaction with concentration of the reaction. Means how rate of the reaction depends on concentration of reacting species. How rate of the reaction is depending on the concentration of reacting species raised to the power their order. Okay, so here we can find what is the order of the reaction. We could write order of the reaction is, here it is x plus y. So here x plus y is order of the reaction, where x is order with respect to a and y is order with respect to b. Okay, and k we represent as a rate constant or velocity constant. Okay, so here x plus y is the rate order of the reaction. Okay, so now we see what is the unit of k. Okay, unit of k comes out to be, what is the unit of rate of the reaction divided by unit of concentration raised to the power n. Okay, so it comes out to be mole per liter per second divided by mole raised to the power n and liter raised to the power minus n. So it comes out to be mole raised to the power 1 minus n and liter raised to the power n minus 1 and second raised to the power minus 1. So this we consider at the rate of the reaction. Okay, so we could write the rate of the reaction for first order by putting n equals to 1, it is first order, n equals to 0, it is 0 order. Okay, so by putting the value of n we can get what is the order with respect to a and what is the order with respect to b. So it was about the rate of the reaction. Now we see two types of reaction. One is elementary reaction and one is complex reaction. So what is the elementary reaction? Okay, any reaction that takes place in a single step. Okay, which takes place in a single step where no intermediate is formed. Okay, where no intermediate is formed or no complex is formed in between the reaction, that is known as the elementary reaction. Okay, now we see complex reaction. Okay, if the reaction takes place in more than one step, if the reaction is taking place in more than one step, then it is a complex reaction. Okay, more and more than one, here more one or more than one intermediate products are formed in complex reaction. Okay, we know more than one intermediates are formed in the complex reaction, that we call the complex reaction. Okay, So according to law of mass action, you know what is the law of mass action? R equals to A raised to the power A, okay, and B raised to the power B, okay, and R becomes equals to K A raised to the power A and B raised to the power B. So for elementary reaction, it is x equals to A and y equals to B. Okay, for complex reaction, x plus y could be equals to A plus B, or x plus y could also not be equal to A plus B. What does it mean? Okay, suppose we have a elementary reaction 3A plus 2B giving 5C. Suppose 1A plus 2B giving 5C, this is an elementary reaction. So rate expression can be written as K A into B raised to the power 2. Okay, so x, what we put here is x, what we put here is y. So x equals to A and y equals to B in case of elementary reaction. But complex reaction, it is not necessary. Okay, it is not necessary. It could be equal to x plus y and it could not also be equal to x plus y. Okay, it depends. Okay, which is experimentally determined. Experimentally determined whether it is equals to A plus B or whether it is not equals to A plus B. Okay, so law of mass action has significance for complex reaction and it don't have any significance with, it has significance with elementary reaction but it don't have any significance with complex reaction. Okay, so law of mass action is valid only for elementary reaction. Okay, this is important. Law of mass action is only valid for complex reaction. It don't have any significance and only in relation with elementary reaction. It don't have any significance with complex reaction. Okay, now comes out to me order of the reaction. Order of the reaction. Okay, so what is order of the reaction? We have seen order n equals to x plus y, the summation of the power in the rate law expression. Okay, in the summation of the power of the concentration of the reactant in the rate law expression. Okay, if rate law expression comes out to be k a raised to the power x and p raised to the power y, then order we can write n equals to x plus y, and it is always experimentally determined quantity. Experimentally determined quantity. Okay, on order of the reaction is could be 0, 2, 3 fractional. Okay, it could be 0, negative, fractional. Okay, but rarely it is greater than 3. Okay, it could be 0, negative, fractional, 1, 2, 2.5. Okay, but it is rarely greater than 3. Okay, it may be negative for particular substance. Okay, order of a reaction depend on experimental condition. Okay, this also depends on experimental condition. Okay, experimental conditions or order of the reaction may vary, may change with the reaction condition. Okay, may vary with reaction condition. How it may vary with reaction condition? We take an example. Okay, 2Hi in gaseous state gives H2 in gaseous state and I2 in gaseous state. If we simple heat the reaction comes out to a second order reaction. Okay, now but when we use Au as our catalyst, so the reaction comes out to be zero order. Okay, so when we have H that simply heating, then the reaction is second order, and when using catalyst as a metal, AU metal, then it is a zero order reaction. So it varies with the reaction conditions. Okay, order can be determined by two steps. One is RDS method. Okay, it can be determined by two steps. One is RDS method, redetermining step method, and another method is steady state approximation method. Steady state approximation method. Okay, later on we will see these two methods. Okay, now let's come to the molecularity of the reaction. Okay, what is the molecularity of the reaction? Now just see, simply molecularity of the reaction is number of reacting species. Okay, whether it is atom, molecule or free radical. Okay, number of reactant species participating in elementary reaction is called molecularity of the reaction. Okay, that is number of reacting species participating in an elementary reaction is molecularity of the reaction. Okay, so what is actually molecularity of the reaction? Okay, let's say we have it only makes sense in case of elementary reaction. Okay, so molecularity of the reaction has no significance in case of complex reaction. Okay, it is valid for elementary reaction and has no significance for complex reaction. Okay, it is valid for elementary reaction and had no significance for complex reaction. Okay, so molecularity, now what is molecularity of the reaction? Suppose there are two atoms that are colliding in a plane. Okay, then the molecularity is called 2. Here molecularity is the 2, so it is the number of atom or species which are colliding in a single plane. Okay, now we see only there are maximum number of molecules which can collide together is 3. Okay, these 3 molecules could collide. If we take an example of 4 molecule, 1 2 3 4, now we see A B C D. B is not touching D and A is not touching C. Okay, so we can see only 3 molecules can collide simultaneously with each other. Okay, so that is called the molecularity. It is number of molecules colliding in a single plane to form a product. Okay, number of molecules colliding in a plane to form product. Okay, now we can say molecularity could be 1 2 and 3. Okay, it is not greater than 3. Okay, because maximum only 3 molecules can collide in a single plane. Okay, so this is the definition of molecule. Okay, it is not observed greater than 3. It can never be it can never be 0, negative, fractional. Okay, it could be only 1 2 or 3. Okay, now if we talk about, now this is the how we calculate the molecularity. Okay, now if we talk about what is the relationship between molecularity and order. Okay, so if we take an example of elementary reaction. Okay, suppose an elementary reaction is 2A plus B giving 3C, and it is given it is an elementary reaction. So if it is an elementary reaction, then molecularity will be 3 and order will be 3, and rate expression could be written as A square into B. Okay, now it is valid only when the reaction is elementary reaction. When it is a complex reaction, we cannot calculate directly. Okay, we have to know the rate determining step for that particular reaction. That is a steady state approximation. Okay, that we will do it later. So molecularity is 3. Molecularity is 3, R equals to K square B if it is an elementary reaction. Okay, so it is called third order reaction, molecularity 3. If we take an example, as hydrolysis of ester. Okay, now for if we write the rate expression, R equals to K CS3 COO C2H5 ester into water. Now we know that water is acting as a reactant. It is also a reactant, but it is also a solvent. So if we see, the concentration of H2O is not changing with time, it is constant. So if we multiply this constant, we can get a new constant. Okay, if we multiply this constant, we get new constant. So write it is K dash into CS3COO C2H5. Okay, now here what is the molecularity of this reaction? Molecularity is 2, because two reacting species are participating, and it is also an elementary reaction. Okay, it is also an elementary reaction. Okay, now what is order of the reaction? Order comes out to be 1. So here it is called pseudo first order reaction. Pseudo first order reaction. This reaction is called pseudo first order reaction. Now, okay, because the molecularity is 2 and order is 1, so it is not necessary that molecularity equals to order. It is not necessary. If we take an example of like one more reaction, 1 plus A plus 2B is forming 3C and B is given in excess. Again here rate we will write K A into B square. But we know this is a constant. Again this will form a new constant K dash into A. So here molecularity will be 1, order will be 3. So this is called pseudo. Molecularity is 3 and order will be 1. So this will call a pseudo first order reaction. So molecularity is equals to order, that is not always necessary. Okay.